Hey, today we're going to talk about 6.10, geothermal energy. So take a moment, check out the Enduring Understanding, look at the learning objectives, pause the video, review the essential knowledge, and set up your Cornell notes. So geothermal energy refers to the energy that is obtained, that heat energy that is obtained from within the Earth's surface. So in the mantle we have tectonic activity, we have radioactive decay of certain elements, and that generates a lot of heat. And remember from our lesson on tectonic plates that we have these plates moving around, and whenever we have a boundary, we have some potential for seismic activity. But another thing we have is we have a potential for obtaining energy from deep within the Earth's surface. So anywhere we have a tectonic boundary, it is potential for geothermal area and obtaining geothermal energy. United States has a lot of geothermal energy because we have, along the western coast of our country, we have plate boundaries. Now another country that shows up a lot in the questions, and it is this tiny little island country right here, Iceland. Iceland is a global leader in geothermal energy, even though they're, according to this diagram, they don't have that much of an output as the United States. But if you consider the size of the country, it is much, much, much smaller than the United States. So, but per capita, a lot of geothermal. In fact, Iceland is a world leader in geothermal energy per capita. So the energy deep within the mantle comes from the radioactive decay of elements like potassium-40. So potassium-40 has a lot underneath the bedrock in the mantle. There is a radioactive decay, and it releases a lot of heat energy. So this heat energy can be used to boil water into steam. Now this diagram is very much like diagrams you've seen before. You would use a cooling tower. You basically what they do is pump the water down, and the water heats up. If you have to dig a really, really, really deep well, and kilometers, like several kilometers deep, to get down to where it is hot enough to convert this to steam. Now, if we were to send the cool water or room temperature water down, it could enter a little reservoir underground where it will eventually boil, return as steam, and the steam can power the turbine. The spinning of the turbine, of course, spins a generator that generates electricity. Now, we do have to cool this water back. If you do add any of this hot water back into maybe a surface reservoir or a lake or a river, you can contribute to thermal shock in different organisms and lead to lower levels of dissolved oxygen. So one thing we must be sure of is that the water is cooled off before it is returned to any environment. Now another thing, this is not necessarily considered geothermal, even though it shows up in geothermal. It is a ground source heat pump. And what happens is, in certain areas where you have geothermal activity, you have a heat pump. So in the summer, you take the warm air and you pump it down into the water, and you pump it into the water, and the warm air transfers the heat energy to the water so that you have like cooler water, and then this warm water is pumped down underground where it releases that excess heat, and then releases its heat, comes back as cooler water, and picks up the warm air, the heat from the warm air in your house. Now in the winter, it's a different story. So in the winter, you have cold water, and because it's cooler, and you pump the water underground, and the ground is warmer than the air temperature, so it adds the heat from the ground and it transfers it to the water, and you pump that warm water back into your house, and then the warm water releases some of that heat energy into the air. So basically, a ground source heat pump cools you, takes the heat and adds it to water, and drops that heat off underground. And in the winter, it takes the excess heat from the ground and brings it up into your home. So in areas where you have access to these geothermal vents or any sort of geothermal activity, the ground is relatively consistent temperature base, and it benefits you in the winter and it benefits you in the summer. So some pros and cons of geothermal. So, first of all, it's potentially renewable. In an earlier video, I said it was a renewable energy source, and sometimes in the College Board, they say it's renewable. Sometimes it can come off. Technically, it's potentially renewable, because if we don't pump that water back underground or wherever we obtain that water from, if we don't pump it back to where we got it from, it is not renewable, because we will be altering natural cycles. One benefit is that it has less carbon dioxide emissions than fossil fuels. There is some carbon dioxide that is going to be released, but it is much less than combustion of fossil fuels. Problem is we have limited access to it. Not every country exists or resides on a tectonic boundary, so they don't necessarily have access to this geothermal energy. Another thing, we have hydrogen sulfide released, and that is toxic to organisms on the surface, and it can be toxic to humans. It is an irritant, and another negative is that it is initially expensive to drill these deep holes in order to generate electricity from a geothermal source. So geothermal, again, is only present in part of the world, and that is one of the biggest drawbacks to why we cannot have geothermal everywhere. So what I would like you to do for FRQ practice is to explain how geothermal energy can be used to generate electricity. I thank you very much for your attention. I hope that this was informative. I will see you soon.